Hi, I'm Ong Jinjay from Group 5 and now I'm going to introduce our proposed power generation plant. So our objective is to design a renewable energy-based power plant with a generation capacity between 100 until 500 megawatt. Our selected source is solar thermal energy, and in this slide contents will cover AutoCAD process flow diagram (PFD), thermal efficiency analysis, and comparison between two given power generation plants. First of all, the solar radiation will heat up the water, and the hot water will flow into the boiler, and the remaining cold water will flow back into the solar thermal, and it becomes a cycle. Then the hot water enter the boiler, will exchange heat to another stream, and the water in the another stream will flow into the turbine. Then the turbine will generate work, and the work will enter the power generator, and the remaining will flow into condenser. The the fluid in the condenser will go into cooling tower and be cooled, and remaining will flow back into the liquid pump and enter boiler and become a cycle again.
Going to move on to the process flow diagram. As you can see here, this is our first section of the process flow diagram, which is the solar thermal loop. So, for the first thing, the solar radiation. What is the function of the solar radiation? The solar radiation, or also known as the solar collector, captures solar radiation to heat the working fluid, which is in this case is the water, from a cold state water to hot water. And then the hot water is sent to the evaporator or boiler. The hot water exits the collector and it is sent to the evaporator or boiler to further heat the hot water to produce high pressure steam. During this process, there are heat transferred to another stream inside the boiler and thus making the water to be cold instead again. So the cold water will exit the evaporator or boiler to be sent to the liquid pump. So what is the function of the liquid pump? The liquid pump is to help in recirculates through the solar collector and back to the evaporator again until the cycle repeats over and over again to produce electricity. The heat that is transferred from the solar thermal loop will be sent to the stream, which is called the Rankine cycle. So at this state, the superheated vapor is produced and an amount of 7 megapascal and 300 degrees Celsius is accumulated, will enters the turbine where it expands isentropically and produces work by rotating the shaft connected to an electric generator. The pressure and the temperature of steam will drop during this process to the values at state 4. So the work out from the turbine will be sent to the power generator, and another stream will enter the condenser. So at this state, the pressure will be dropped to amount of 75 kilopascal and enters the condenser. And usually at this state, the steam is usually a saturated liquid vapor mixture with a high quality. So the steam is condensed at constant pressure in the condenser by rejecting heat to a cooling tower. So as you can see there, the hot water is exits from the condenser to cooling tower, and then the cooling tower will then reject the waste heat from condenser to the environment, resulting to return the cold water to condenser loop. So the liquid will be sent to the liquid pump, and it then will be raised the pressure of condensate from 75 kilopascal to 7 megapascal and recirculates back through the boiler.
So next we go to the calculation part. So there are 4 stages. For the stage 1, it undergoes saturated liquid with a given pressure 75 kilopascal. So basically, we just refer to the appendix and find the value of enthalpy, entropy and the specific volume. So for the stage 2, it undergoes compressed liquid with a pressure 7 megapascal. So in this case, we use a work pump equation, and from the work pump equation, we can find its enthalpy. So for the stage 3, it undergoes superheated vapor with a pressure 7 megapascal and temperature about 300 degrees Celsius. So we just refer to the table of superheated vapor and find the enthalpy and the entropy value. So for the last stage, it undergoes saturated mixture with a given pressure 75 kilopascal, and the entropy for stage 4 is equals to the entropy for the stage 3. And then we just perform the calculation by using this equation, and find the equality and enthalpy of it. To find workout in turbine, we basically use a second law of the thermodynamic equation. So we given the mass flow rate and the enthalpy that we already calculated, we just substitute into the equation and find the workout, which is a 219.8646 megawatt. And for the specific Q out in condenser, we use just same formula like a workout turbine, and from that we substitute the value and we get the 1722.578 kilojoule per kg. Same goes to the specific Q in a boiler. We use the same formula and we get 2448.2788 kilojoule per kg. So from that, after we find the Q in and Q outs, we can find the thermal efficiency, and from that we just substitute the value into the formula, and we found that the thermal efficiency around 29.64%. From our calculation, we interpret it into Rankine vapor power cycle diagram. So this is our overall diagram of Rankine vapor power cycle.
So now we are going to compare two types of power plant generators, which is the first one is the solar photovoltaic system, and the second one is our proposed power plant, which is based on a reheat regenerative Rankine cycle. So let's break it down across the key parameters. So the first parameters will be the thermal efficiency, where the solar photovoltaic system has a thermal efficiency of 44%, which is significantly higher than the proposed power plants, which is the efficiency is 29.64%. But when it comes to capacity, the proposed power plant will lead to a total output of 219.86 megawatts compared to 40 megawatts for the solar photovoltaic system. So while it less efficient, it can produce a much larger amount of energy. And for the process cycle, the solar photovoltaic system use a net meter solar photovoltaic grid integration, and this means the electricity will generate is either used directly or fed into the grid. And meanwhile, the proposed power plant use a reheat regenerative Rankine cycle, which is a more complex thermodynamic process designed to enhance performance in thermal plants. And next is the fuel source for the solar photovoltaic system is the pure solar power, which is it will directly convert sunlight into electricity. And on the other hand, the proposed power plant will use sunlight thermal energy, which typically involve concentrating solar energy to produce steam and drive turbines. And in case if the primary sources is unavailable, the solar photovoltaic system will rely on battery storage to supply power. And as for the proposed power plant, however, it will switch to a biomass as an alternative fuel source, which is a renewable organic material. And as for its environmental impact, well, each system will has its own environmental concerns, and the photovoltaic system will generate toxic waste if the recycling isn't done properly, but it also can contribute to reducing the greenhouse gas emissions, as it will eliminate the needs for the fossil fuels. And for our proposed power plant, it will face the challenges with the solar panel waste at the end of their lifespan, and recycling and disposal will remain as a problematic things.
Next, I'll be comparing our proposed power plant with CJ Andrasen and Berhad. For the thermal efficiency, CJ Andrasen and Berhad has higher percentage with 45.5%, and as opposed to ours, which is 29.64%. This is because their capacity is way higher than us with 1,400 megawatt, as opposed to ours 219,8646 megawatt, and their process cycle is subcritical coal fired, and we use the Rankine cycle power plant, and the current or main fuel source that they use is coal with their alternative fuel source, which is diesel. Ours is sunlight thermal energy, and our alternative fuel source is biomass. And the environmental impact of using both fuel source is that CJ Andra has the potential to release sulfur dioxide, which is harmful for respiratory system and also one of the major contributor to haze. And the environmental impact for solar PV or solar panel, it is that the waste, particularly at the end of lifespan, poses a challenge for recycling and management. This is the process flow diagram for CJ and Android